Testing, testing. Test. Test. Turn you down just a little bit so you're not clipping. Test. There we go. Good morning, everyone. Hope everybody's doing today. Doing well today. Pardon me. Looking out at your Mr. Moore weather report for this morning. Looks like it's gonna be a beautiful day out there today. The sun is shining. The birds are singing. The buds are budding. It's just spring. Man, happy last day of March. Well, maybe it's the second last day of March. Nope, yep, it's the second last day of March. Happy second last day of March. Our last lecture for March, anyway. How is everybody today? Hope you guys are doing well. I don't really have any, have I considered going into Opera? No, I am nowhere near a, nowhere near a sufficiently trained person to go into Opera, for sure. It's just, you know, well, it's kind of interesting, actually, because, you know, in order to give a lecture, you have to use a certain amount of the vocal technique that, you know, you would traditionally associate with opera. I know that, like, I'm talking to a microphone now and not a room. But, I don't know, let me have this, you know? Let me feel as if I need all of the vocal technique that I have developed over the course of my lecturing career. But, yes. Just to confirm, if you MSAF test 3, the weight will be distributed to test 1 and 2. Yes. That is truth. However, you would never dream of using an MSAF when you weren't actually, like, medically unable to write the test, right? That's what MSAFs are for, right? They're not just a get out of a test or an assignment free card. Also, you know, if you are unable to write the test, I would highly still recommend it as practice for the exam. So, yes, good, excellent. Of course, good. Just so long as we're all on the same page. So anyway, we were talking about files last time around. We were talking about file formats. We were just about to get into file formats. So, you know. So we've talked about how to get at the data that's sitting on your hard drive, right? You have, once again, a distinction between permanent memory and impermanent memory. When you create a variable, that's impermanent memory. That is random access memory. That is memory on your RAM cards, roughly speaking. When you're dealing with files, you are dealing with things that are stored in permanent storage. Read-only memory, ROM. In the, way back in the day, that would have been stored on magnetic tapes. Going forward a couple of decades, magnetic disks became very popular. They're so popular that most hard drives to this day are still magnetic disk drives. The way that works is you have like a disk that looks a little bit like a CD-ROM, and you have a read head that reads the magnetic state of cells that are like microscopic on that hard disk, which is kind of cool. It's kind of cool that such a thing could even exist. These days, things are moving more and more towards solid-state drives. So, it's kind of like a bigger, bulkier version of a USB thumb drive. You know, since it doesn't have to communicate over a universal serial bus interface, it can be made much, 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 much faster. Which means that, you know, the load times on your Switch are much better than the load times on any game that you would have on a game console that had a hard drive rather than a solid-state drive. But anyway, so, talking about files. We're going to talk about files. Let me just check, see. Doop-a-doop-doop. Yes. Yeah, yeah. I mean, to me, that's more of a gray area. If you realize, you know, if you got so busy that you missed something, it's like, you know, to me, that's kind of more of a gray area. You know, one could make the argument that, you know, forgetting that there's a test could be an aberration of the normal function of your brain, but, you know, it's a little bit, yeah, but, you know. Anyway, I'm not going to tell you what I think about the MSAF policy, but you can probably imagine what I think about the MSAF policy. Anyway, so when we talk about file formats, you know, there are as many file formats that are possible for a computer system as there are, you know, trees in the woods. Like, every program that anybody ever develops could hypothetically use its own file format. What a file format is it's a data policy that dictates the structure of the characters in a file, or the bytes in a file, depending on whether it's a binary file or a character-encoded file. So you should be thinking about file formats in the same way that you think about the data policies that we enforce with classes. So we're going to talk about 3 file formats, plus a little bit about HTML. We're going to talk about comma-separated value files, JavaScript object notation files, and extensible markup language. So, CSV files, comma-separated values. A good way to think about a CSV file is as a plain text spreadsheet. It's not a perfect analogy. CSV files can't do many of the things that a spreadsheet does. Like, for example, since it's plain text, there's no way to do formulas or anything. You know, there's no way to do graphs. There's no way to do bold, italicized, underlined, etc., etc. What it is it's sort of a rectangular arrangement of data. It is a tabular... basically, it's a way of encoding a table as a plain text format. So these guys are very, very commonly used. In fact, of the 3 that you see here, probably CSV is the one that you would see most frequently in the wild, so to speak. So it's very, very common. It's a common file format for transferring data. So, for example, when we transfer your grades from Jupyter into the master gradebook on Avenue, do you think we do it one at a time? We do not do it one at a time. We get Jupyter to export for us a CSV file that contains all of the data that Avenue needs. I think we wash it through a quick Python script that just formats the CSV data so that it's sort of in the configuration that Avenue expects it to be in, so that Avenue can read it, and then we just feed it in automatically to Avenue, and it's like it automatically populates the grade items with the grades directly from Jupyter, because of course you guys know that the autograder system itself is bound to Jupyter. We can't get that to run in Avenue for obvious reasons. You know, Jupyter's built for it. So, so yeah, the CSV file is the means of transmission. It is the medium for grade transfer between Jupyter and between Avenue. And you can also get it to do... you can also get Mosaic to accept a CSV file from that you generate on Avenue. Although, generally speaking, if you want to know the God's honest truth, I find that in the personal experience of your humble professor, Mosaic, the sort of grade import functionality is on Mosaic is like sufficiently faulty that like I have to double check, triple check everything anyways, and sometimes it's easier just to do it by hand, no matter how big the class size is. But it also it depends on how codey I'm feeling, you know, whether I want to mess around with this. You know, if it's only like 100 people, it's not that bad to just enter it manually. But you know, the bigger the class size gets, the more of this you tend to want to do, because you know, automating tasks, it takes a certain amount of time to automate a task, but you know, the amount of time you save by automating a task is multiplied by the number of times you would have had to do that task. So, you know, if it takes you amount of time to automate a task equal to, like, entering 30 grades, for instance, then, you know, whether if you only have, like, 30 grades to enter, it's like, you know, you're neither one nor the other. But if you have, like, 500 to enter, that's a critical time saving. And, you know, it's kind of just the way that life on this planet is going, that, you know, if you have the ability to automate these types of data processing tasks using code, you should be doing that, because that's a very employable skill. You know, the ability to automate small tasks allows you to become a more efficient person, which means that you're, you know, a more valuable employee and that sort of thing. But anyway, so the way that a comma-separated value file works. Each line in a CSV file is one entry in a data record, right? It's like the rows in a spreadsheet, right? Each row is a different entry. Each record of the file contains multiple fields separated by commas. You can optionally have a header row containing field names. And one of the interesting things about CSV files is there's no one definition of the format. It's kind of like it's generally accepted that it's values separated by commas, but sometimes people don't use commas, sometimes people use the bar character, sometimes people use space instead of comma. So, you know, regardless as to whether or not it's a comma-separated value file or a, you know, space-separated value file, the general format's going to be pretty much the same. So you can rely on it reasonably well. But, you know, as I said, when we transfer grades from Jupyter to Avenue, or from Avenue, certainly from Avenue to Mosaic, we have to wash it through a Python script to reformat the data to get it into the format that the system we're importing it to expects. So, there you go. So, let me see if I can't, yeah, here's an example. There's an example in the course content as well, I believe. I think it's, Never mind. I thought there was a CSV file in here, but I guess not. Anywho. So, we've got a set of tabular data here. Last name, first name, MAC ID, grades for assignment 1 and 2. And if you compose that into a CSV file, this is what it looks like. Last name, first name, MAC ID. Notice everything is comma separated. Because it's being comma separated, we can include spaces. So, it's kind of like the single quote versus double quotes for Python strings, right? If you're using double quotes, you can include single quotes within the string. If you're using commas, you can include other, you know, other characters that might denote the space within the context of the CSV file. Let me see if we have any questions. For any text-based file type, is there a limit for how much data can be in a line, or does the line continue until a new line character has been reached? It's hypothetically infinite, my friend. It's hypothetically infinite. So, that's actually an interesting point, though. Whereas, with most other data formats, like if you imagine, like, producing something like this in a MS Word document or something, MS Word sort of implicitly, like line wraps, so that, you know, if what you type exceeds the size of a line, it just automatically puts it on the next one. Within an environment like this, you don't necessarily get that. You can just have a line that's as long as you want it to be, right? Notice that line number 5 has like 3 actual lines to it. So I think I can go into the options and turn off word wrap to show that more, you know, more clearly. But yeah, it sort of depends on your whatever file editor you're using, whether you'll get a scroll bar at the bottom, or whether you'll just, you know, do word wrapping. Notepad, you can configure it either way. But yeah, the actual length of the line is, I believe, I don't know, you might start running into problems if you exceed the size of a, like a 30, or if you exceed the size of a 32-bit integer, you might start running into problems, but the size of a 32-bit integer is very large. And that's kind of like, you start running into problems all over the place if you start getting up that high. So, you know, 2 to the power of 32. Maybe you might be limited to 4.29 billion characters, but, you know, that would just be a guess. Obviously, I've never written a line with 4.29 billion characters in it. Although you could generate one in Python easily enough. So, this is a Python class, though. So how on earth are we supposed to use CSV files when we're using Python? Well, it turns out it's actually pretty easy. We have a CSV module, a library module, which allows us to work with CSV files in a reasonably compact, lovely little manner. So, it's actually quite simple. Just gonna comment this guy out. Import CSV. I suppose I'll need a CSV file, won't I? Get it. Example.csv. And I'm just gonna copy that stuff off the slide. That'll be good enough. Ta-da! So, if we import the CSV library and open the file, so in this case, it's going to be example.csv in read mode. Pardon me, sorry. That was probably RIP headphone users. Sorry, guys. Yeah. Then if we... So the important line with the CSV reader, or the CSV module, is this guy right here. Grades equals csv.reader file handle. As file handle. So in the same way that we use the file handle object and use the read and write functions to access the file, we create a CSV object, which basically we create a CSV object by applying a CSV interpretation to the file handle. So it's csv.reader file handle. This actually generates an iterable object, so we can for loop over it. Oh, this is the wrong directory entirely. Well, that's silly. All right, this is the right directory. My goodness, how silly. There we go. There we go. Now, Python 3, topic 9.py. And you can see, when we print these rows, what it does, what the CSV reader does, is it takes each of those rows and interprets them as a list of strings, right? So the first row here is a list of strings, which are each of these guys. The second and third and fourth rows are also lists of strings. So you can kind of think of the whole enchilada, the entire CSV file, as a list of lists of strings. And once again, notice that although this data is ostensibly numeric, the CSV reader interprets it as a number. Or, pardon me, it interprets it as a string that contains numeric characters. So, if you want to interpret that data as being numeric, you'll have to perform whatever conversion function you want. In this case, it would probably be int. So, that's cool. So, let's see, any questions? No, just comments on my sneeze. So that's the regular reader. But you may notice that we have, on this CSV file, a header row. We can actually use this header row to do a slightly more useful interpretation of this CSV file. We can actually, rather than generating lists of strings, we can automatically generate dictionaries, where the header row is the key, specifies the keys, and each row specifies the values. So, our files. If we use Dict Reader instead of regular reader, where are we here? There we go. Dict Reader. Then you'll see that we get ordered dictionaries. So an ordered dictionary is basically just a dictionary that maintains ordering. It's not, you know, if we interpret these as regular dictionaries, they should show up in the way that you would expect a dictionary to. Yep, there we go. So these are dictionaries. We can use them as if they were dictionaries. You know, if we want to print just each row at the tag A2, then it'll give us just the A2 column. That's actually extremely useful, right? The alternative to that is just knowing what index the column you want is, but this allows you to refer to things, you know, phonetically, or with words. So yeah, that's how you read. Writing to a CSV file, highly similar process. So, let's say we wanted to be super, super generous, create a new CSV file where all of the grades in the old one were doubled. Right? Let's do this as a regular reader. New grades is equal to an empty list. New grades dot append row new grades at well, actually, we'll just for row in new grades, row at 0, 1, 2, 3, 4, 3 and 4. 3 is equal to row at 3. 3 times 2. Row at 4 is equal to, wait, did I get that right? 0, 1, 2, 3, 4. Yes, I did. Okay. Row at 4 times 2. And let's just print this just to make sure that we're not completely crazy. Ah. Let's integer interpret that. Right? I forgot to do the integer interpretation, so multiplication by 2 on a string repeats it. Right? That just illustrates the importance of that thing that I said and then forgot to do. So quick tip. If you want the thing to just do nothing, if it encounters an error on an iteration, you can just put it in a try loop without an except block. Unexpected indent. Maybe you can't. Maybe you have to have that in there. And then a pass. Alright, let's see. Yeah, there we go. All of these grades have now been doubled. And now, if we want to write it back into a CSV file, with open new grades.csv in write mode as file handle, then we pull in, we create a CSV writer object, so grades is equal to csv.writer, give it the file handle. Basically, this just puts a layer between the file handle and you that interprets everything you do as a CSV file, which is pretty cool. JSONs work different, as we're going to see. So, for row in new grades, grades dot write row. There we go. Now let's see. Let us see. Did it create it? New grades, yes. Cat new grades.csv. There we go. All of the correct modifications have been made. Ta-da! So there you go. That's how you... And that's actually a reasonably common sort of thing that you would want to do, is read in a CSV file, make modifications to the data, and then write it back to a CSV file. Couldn't you just iterate through each row in grades and then double them with a loop? Well, no. The problem with doing that is that grades is not a data structure per se. It's a class that contains data. By doing this guy, I'm taking the data out of the... It's like you wouldn't presume to modify data inside of the file handle. In the same way that you wouldn't perform direct modification of the file handle, don't perform direct modification of the CSV reader object or the CSV writer object. You gotta get that data into a secondary location. You gotta get to a secondary location, and then you can do anything you want to the data. Like, I don't know. But yeah. The grade object is a CSV reader object. Although we can interpret it as, we can use it in much the same way as we would use any other data structure because it has iterable defined for it. That doesn't make it a list of lists, right? You should construct the list of lists. There you go. Is there a less tedious way to double the grades then? No. I mean, maybe, but I don't know. This is these is... I mean, I don't know if this is excessively tedious. It divides itself into the 3 basic operations that you have to do pretty easily. You read it, you deal with it, then you write it. You know? Those are like... No. This is the work that it takes to perform that task. I don't know. I always get in trouble when people are like, isn't there a more efficient way to do that? And I'm like, well, not really. And then somebody inevitably comes up with a more efficient way to do that, you know? But, because that's the way that coding works. But, you know, this is a definitely, you know, this is not a bad way to do it, you know? This is about as much work as it takes. But yeah, okay. So, if your data is already represented as a list of lists, then you can write it out all at once. So if you don't want... here's a simplification for you. If you don't want to loop over all of those things in order to write them, you can remove the loop and just go write rows, and it'll just write all of the rows. It'll automatically loop for you. So there's a simplification for you. Except you have to actually provide it the thing that has the things. There you go. Ta-da! So here's a question. What if you want to include a comma in one of the things that you're working with? Within the CSV file format, you can always sort of directly make something a string within these within the context. Like if your value contains the character that's being used to delimit the elements of the CSV file, you enclose that in quotes, and then that will perform the interpretation correctly. So, for example, if I say Alice, princess of the Minecraft, why not? Then you'll notice, as long as we have enclosed it in quotes, it's written correctly. And these guys, like if this were taken as 2 separate entries, we would have been doubling these 2, not these 2. And that's not how it worked, so it's good. Other considerations, and these are sometimes the first one here is these are things that are often you just have to consider when you're working with plain text in general. Sometimes like accented characters from other alphabets, like, you know, Hebrew and Cyrillic and Mandarin and all kanji and all of these different characters that are used by languages other than English. These are typically stored in the sort of higher up character values, and you have to be careful with your, you know, in the same way that when you're dealing with things on the internet, you have to be careful with the character set being interpreted correctly. You also need to be worried about the character set being interpreted correctly when you're working with plain text formats in general. Generally speaking, it's not really an issue, but, you know, just something to be aware of. Just, normally there will be an option when you're importing something in a sufficiently complicated system for, you know, selecting the character encoding that you're using in this particular file. The other thing, sometimes people use other delimiters rather than commas, like tabs, vertical bars, or spaces. Yup. just a thing to keep in mind. CSV data can be exported from any spreadsheet application, but of course macros and formulas will be lost. You'll only get the values they result in. You can get data from many financial websites. I'll leave that as an exercise to the reader. So let's talk about JavaScript object notation. This was originally a subset of the JavaScript programming language, which is used specifically for representing objects. Objects in the same way that we've been using objects in Topic 8. Over time, people really liked the way that JSON handles this type of data, so it's now like morphed and evolved into a very general purpose language-independent plain text format for representing dictionaries, lists, and structures composed of both of those. So, the JSON files are commonly used for transferring objects between applications. So the data contained in an object. You remember when we were talking about enforcing data policy and like the family tree example for classes. JSON file is your native format for transferring the information that you would have contained inside of, a list of person objects to some other programming language or to some other application. JSON is actually, it's becoming increasingly popular in databasing applications. We'll sort of get more into this when we talk about, like, we have a unit on databases coming up, but essentially you have like the old way of doing databases, which is called relational databases that use SQL. Those are the type that we're going to be covering in class. You have this new generation of databasing programs that don't use relational databases. They don't use the relational database model. They use JavaScript object notation as the underlying data carrying paradigm. So everything's kind of under the hood stored as a JSON, which is kind of interesting. So this is a popular format, but it's mostly popular among people who program. So the basic idea is that overall, the entire file is either a list or a dictionary. Every entry in the list, or every entry in the data structure at the top level can be one of the following things. Either a list, a dictionary, a number, a string, a boolean, or a null value. So, think of it as a hierarchical structure that contains lists, dictionaries, and it's lists, dictionaries, and values, essentially. So when you're talking about dictionaries within the context of a JSON, although in Python the key to a dictionary can be anything, in JSON files it must be a string, like a quoted string. So the value can be, again, any one of these guys. So that's kind of cool. So what are JSON files actually used for? Well, I'm so glad you didn't ask. The assignment files that we use are actually JSON files. So if I take a look at the t1.ipymb, which is, of course, the source file for the first test, this is a JSON file, folks. So we've got a dictionary at the top level. We have a cells entry in that dictionary. That gives you like the actual cells that compose the document and their contents, like what type they are. You can see that it's a list that contains dictionaries. Each cell says what type of cell it is. Is it markdown, which means it contains text, or is it a code cell? It has the source, quote unquote source, but that's really just the contents of the file, and it has execution count, metadata, etc., etc. You know, this is a JSON file. You can see the way they store the contents of these files is each line in a markdown is kept as a separate string terminated in a new line character, and then it's a comma delimited list of all of these. So, yeah. JSONs. Let me see if you have any questions. Ha! I mean, yeah, I use exercise for the reader in a slightly different sense than the math textbook that you're referencing. For me, it's like, I don't care to. It's like, I don't care to click that link for you. You may click the link if you want. I don't think it's important enough to discuss. Yeah, for me, exercise for the reader is like not important enough to discuss. But you know, our lecture time is limited and valuable after all. So, going back to our example, our JSON file example, sorry, our person object example from the previous lecture. You know, we have a list of dictionaries. We have a number of, like each dictionary here represents one object. Typically, a dictionary will represent an object where the keys to the dictionary will be the variable names that the object uses. But yeah, so that's kind of how you would do that. One of the interesting things about JSON files is white space doesn't matter. White space is irrelevant. So you can format, you know, these guys any way you like. You can put them all in one line. You can space them out, you know, over multiple lines. Typically, you put one entry per line. That's like a good way to do it, but, you know, it's kind of up to you. If you want to read a JSON file in Python, the process is a little bit different. Rather than sort of creating an object that intermediates between you and the file handle, you actually just dump everything out. Like, you just read the entire file into a string, and then if you call json.loads, it takes that string and converts it into a basically it parses the string as a JSON object, or it parses it as its represented data structures. So, for example, let's take this T1, just for the sake of argument, drop it. Oh, we actually have A2 already in there. So let's just rename that something useful. So with open a2.ipynb in read mode as file handle, we first grab the entire contents of the file. So fh.read, is it read or is it, yeah. Yep, fh.read. Then our, what do they use here? X? Yeah. X, the structure itself is json.load string s. Of course, we're going to have to import JSON. So I'm going to level with you right now. It's entirely, like, there's a very, very high probability that you're going to see either a CSV file or a JSON on the final exam. Now, a pitfall that people traditionally have when I give them one of these data formats on the exam is that they don't use the library, and I never understand that, because, like, you can make your life so much easier by using these libraries. I write the questions expecting your first instinct to be, oh, I'm using a JSON file format. I should import the JSON library. You should say that to yourself immediately. That should be the first place your brain goes. But anyway, so if we just print this and see what it looks like. Badoop. There you go. You can see it's not presented very prettily, but this is, this is how Python that's how it shows things. So if we take a look at cells, number 5. Oh. Right, because it needs to be in a quote, because it's a string, of course. There you go. This is the contents of cell number 5 within that JSON file that constitutes assignment 2. Yeah. So there you go. You can work with JSONs. You can get at the stuff inside of JSONs using a combination of key addressing and index addressing, however that thing is meant to be interpreted. Are there any questions about any of that? We'll go into writing JSONs next time in class. Okay? Let me know if you have any questions. And while you're writing those questions, I'll be right back. Give me 2 seconds. Hello, I'm back. You guys don't have any questions? Not even about the test on Saturday? I suppose this is the third one, right? So it's getting pretty routine at this point, eh? Anyway, I just thought I'd bring the kitten over to say hi. Say hello. Yeah? Are you a little sleepy? Little bit sleepy. Well, I mean, if nobody has any questions. Our files on the test. Yeah. Files will be on the test, but not the file format stuff. The test coverage stops, like, at this slide. So this bit here. We'll do some simple file stuff where you have to read and where you have to, you know. Can you go to tutorials to get help on questions from previous assignments? Yes, absolutely. You can also go to the TA's office hours. We've got office hours running for every day of the week. There are office hours. Each TA is assigned to a different day of the week. Mine are on Thursday after class. So yeah, if you want to raise those questions in tutorial, please feel free to do so. If you want to raise those questions privately during office hours for any of the TAs or myself, you're also absolutely welcome to do so. Yes, absolutely. Yes, please seek the help. Seek the hope. Ask and ye shall receive. Knock and the door shall be opened unto thee. Seek and ye shall find. Yes, yeah, the office hours are on Teams. The specific times for each of the office hours are listed in the course syllabus, which may be found, of course, under Content, on Overview, Bing Bang Boom, Overview. There you go. There you go. Right at the top. So today is Tuesday. So that will be Swale. His is starting at 12:30, so his office hours start in an hour. Swale's a good guy. Okay, well, I guess I'll let you guys get to your classes then. Have a good day. Have a good Wednesday as well. We'll talk to you guys on Thursday. And that's it. Da-da-da-da-da-da.